if you could have a magical ability to actually see all the air molecules in the air, you might see something like this. It would be a lot more crowded, but you could imagine it might look like this. And let's say that you actually decide to do something a little interesting, and that is to take a jar and simply capture some of the air molecules in your jar. So I've got my jar here, and I'm actually going to put a little opening on my jar. So let's say there's a little opening there, and I take that opening and I'm going to just make it kind of a stretched out neck. So this is my stretched out neck on my jar, and there's the opening to my jar. And on the other side, what I want to do is actually kind of compare what's going on inside of my jar to what's going on outside of the jar. So to make it fair, let me actually try to create a purple box, kind of a dashed line around an equivalent volume. So this is going to be basically a similarly sized part of the air. And of course, this dashed line is just to show you which part I'm talking about, because of course, this is an imaginary line. But let's say we're comparing what's going on inside of my blue jar with what's going on inside of this purple dashed line. Now, we know that that purple dashed line is kind of capturing a certain amount of the air in the atmosphere. And that air is going to have molecules that are bouncing off of each other. Let's say something like this. And you've got a bunch of kind of random collisions happening. And these collisions, the more frequently the collisions are happening, the higher the pressure in the air. In fact, measured pressure in the air is around 760 millimeters of mercury. So that's how we think about air pressure. So that's the pressure in the atmosphere. And if I was to measure my jar pressure, it would be, of course, the same thing. It would be 760 millimeters of mercury. And as a quick aside, just thinking about what these molecules are, if there are 5 of them, then you might say that this is nitrogen, this one is nitrogen, this one is nitrogen, this could be nitrogen, and this one might be oxygen. Because remember, oxygen is about 21% of air, and so that might be a fair estimation of what these 5 molecules could be. Mostly nitrogen. So in the air, we've got nitrogen and oxygen is bouncing around in my jar just as it is in the atmosphere itself. And now let's say I decide to do kind of an interesting experiment. I decide to drop the floor, just stay with me here, I drop the floor of my jar. So I actually expand the bottom of my jar. And for the moment, don't worry so much about how that could possibly happen. Let's just assume that I do creatively somehow kind of drop the floor. And now it looks a little bit lower, so the volume has gone up in my jar. And actually simultaneously, I just want to mention here that this door or opening of my jar is closed at the moment. So my opening, I've put a lid on it. So that's closed, and my floor just got a little bit lower. So the volume has gone up. That's the big change, right? Actually, let me write that up here in the corner. I'm just going to erase some of these molecules to create some space. And the first thing I want to mention is that the volume has gone up in my jar. So all the green stuff I write in the corner is going to be from the jar's perspective. If the volume goes up now, if that's the case, then these molecules inside the jar, they're excited. They've got more room to kind of run around and play and not bump into each other. So if they're not bumping into each other as much, because of course they've got all this extra space down here, then the pressure on the inside of the jar is going to go down, right? Because there are less collisions happening. So now we've got, let's say, a slight decrease. It went to 757, so a little bit less than what's on the outside. So because the volume went up, the pressure went down. And again, that's because you have fewer collisions. And the new pressure is 757, which is a positive number, but sometimes people refer to this as negative pressure or a vacuum. And the reason they're saying that is because they're saying, well, relative to 760, relative to this number, 757 is 3 points lower. And so in that sense, it's negative. So if you actually want to look at them, compare them to each other, you'd say, well, 757 minus 760 is negative 3, and that would be a negative number. But for the time being, I'm just going to leave it in the numbers we have, which is 757. Now, let's say that I open this door. This opening is now open. If I open up this opening, what will happen? Well, we have all this extra space down here. I circled, but I'm just going to kind of remove this for the time being. All this extra space. And molecules, of course, are being knocked around all the time. So there's these collisions happening always. And some molecules are going to get knocked perfectly so that they actually kind of move into the jar. Let's say it goes in like this. So you're going to get some molecules going. And in fact, you might have some molecules that kind of get knocked right out. So it's going to happen constantly. But overall, what's going to be the net difference? Well, let's say I leave this and I kind of walk away and do my own thing for a minute and come back. I'm going to notice that there are actually extra molecules on the inside of my jar because there's more space, less crowding in my jar because of all that extra volume I created. So over time, there's going to be a few extra molecules in my jar. And maybe I got lucky and this one's an oxygen molecule. So I've got extra molecules on the inside. And these molecules, so actually that would be, I guess, the next step is that air molecules move in. Air molecules move in. And these molecules are now going to do what molecules do, which is kind of bounce off of each other. So they start bouncing off each other. And all of a sudden, now you've got, let's say this guy collides over here as well. And maybe there's some bouncing, this collides over here. So now you've got, because you've got 6 molecules on the inside and, kind of the same volume, the pressure on the inside has gone up. So pressure has gone up on the inside of the jar simply because there are more molecules in there now. So even though you had more volume initially, you've kind of filled it up with more molecules. So the pressure goes up, let's say to 760 millimeters of mercury. So now it's gone back up. So this is my new pressure. And this all happened, this whole kind of series of events happened because I decided to move the floor. Now what would happen if I decide to move it back? Let's say I decide to kind of go back to the original floor size and I kind of get rid of this lower line and I raise the floor back up. And so now it looks something like this. Well, now the volume, this is kind of the new first step. What's going to happen? The volume has gone down. That's obvious because I just moved the floor purposefully. And I've got 6 molecules in my jar and they're thrashing around, bumping into each other, but they've got less space to do it in. So the pressure is going to go up because there are more collisions. They're bumping into each other more. So the pressure is going to go up. Pressure is going to go up now to, let's say, 763 millimeters of mercury because it was 760. And at this point, let's say this is closed up. And so the pressure on the inside is 763 millimeters of mercury. Let me erase this. And that's because, again, you have more molecules, but you reduce the volume. So then the pressure on the inside is actually now higher than the outside pressure. I mean, the outside pressure is always going to be around 760, and that's because the atmosphere is just enormous, right? So the movement of a few molecules this way or that way is really not going to change the amount of collisions that are happening in the atmosphere. That's always going to stay the same. And so if I was to open this door up, then some molecules, of course, are going to be bouncing around, and some of these things might kind of bounce out. So some molecules might kind of bounce out. And overall, again, on the whole, you're going to have more molecules bouncing out than bouncing in because you have more collisions happening on the inside. And again, when I say more collisions in your mind, I want you to think of higher pressure. So if there's higher pressure on the inside and more collisions happening on the inside, you're going to have more things bouncing off each other and molecules are going to be sent outside. So the next step I could write in would be air molecules move out. Air molecules move out. So the final point is that if air molecules are moving out, let's say just by random chance this oxygen molecule happened to be the one that got sent away, so this one kind of got knocked out, then you have, I'm trying to erase all this to clear it up, then you have 5 molecules again on the inside, and you have the same kind of volume that we initially start out with. So the pressure on the inside goes back to what it was in the first place. The pressure falls to 760. And the reason that I say exactly 760 is because this process in step 3, this step will continue until the number of collisions on the inside and outside of the jar are equal. So this is kind of the process. And actually, I forgot to mention, when we were back at 763, sometimes people call this positive pressure, for the same reason they called it negative before, because all they're doing is they're comparing 763 to atmospheric pressure, which is 760, and saying, wow, that's a +3. That's a little bit positive. And so when you compare things relatively, you use words like positive and negative. But if you're using just the total number in kind of absolute terms, then you would stick to 757 or 763. Now, what does all of this have to do with us? What does a jar and an opening have to do with human beings? Well, let me just show you that by simply changing my drawing a little bit, you'll see what this has to do with us. Now, instead of having all the molecules inside the jar, I know that you know they're there. I can actually erase all this, and maybe I can change the shape of this a little bit to help you see what this could be. So let's say I make that like this and start drawing in like that. I'm going to keep all this kind of the same in terms of the way it looks, maybe like that. And you can see now, instead of a jar, what I'm creating for you are a pair of lungs. So this is a pair of lungs, left and right. This will be right and this will be left, and it'll look something like this. And this one might go up like that around the cardiac notch and go like this. And then we have, of course, the opening, which if instead of calling it an opening, I could call it a mouth. This would be my mouth, and I could erase the word opening completely, and I think you'll start seeing how this is basically what happens in our body. So our head represents the opening of this, and this could be the nose, and this could be the head, kind of a flat head I have drawn here, but you get the idea, I think. So there's your nose, and there's your ear, and basically air is coming in the mouth and going into the lungs and back out of the lungs. And what we call this process is inhalation. So when you increase the volume, we call this inhaling. So if you've ever wondered, it's exactly what happens when you inhale air. There it is. And when you close up the lungs and air molecules move out, we call that exhaling. Actually, I should probably try to make it look the same. They're both equally important, so I'll draw them the same way. Exhaling. And now you can see how inhaling and exhaling happen. So with every breath, this is the process. You kind of subtly change the volume, and all of a sudden the pressure changes, air moves in and out.